Welcome back, 9th standard students. So, yeah, we started off with the chapter number systems, right? And in the last, few videos, uh, we talked about rational numbers. We talked about, irrational numbers, right? So we introduced irrational numbers. So now continuing with certain properties of rational numbers and irrational numbers. Um, rational numbers, when you divide it, when you present a rational number in a decimal form, there are two main attributes of rational numbers that you will be able to observe. Either rational numbers, when it is expressed in the decimal form, will be terminating, which means that the decimals will end at some point in time. Okay, so for instance, if you take rational numbers of the form, let's say 20 by 8, right? So when you do 20 by 8, what happens is, it basically, or 2 by 8, it basically stops at some point. The decimal stops, isn't it? So it is a terminating decimal. In case if it does not terminate, okay, if it do not terminate, as in the case in 2 by 7 or 3 by 7, you will find that a block of numbers will keep recurring, which means a block of numbers will keep repeating in a pattern, right? So if the decimals are non-terminating, then it will be recurring in the case of rational numbers. But at the same time, when you are representing an irrational number in the decimal form, then an irrational number will be a non-terminating. Okay, so there is absolutely no irrational number when it is expressed in the decimal form will be terminating. So it is non-terminating, and second, it is non-recurring, which means you will not be able to find a pattern in the decimals. The way the numbers are getting repeated, you will not be able to find a fixed pattern. You will not be able to say, okay, this block of 5 numbers will keep repeating. You will not be able to arrive at that pattern. Okay, so this is the characteristic of irrational numbers. So you have to basically remember that when a rational number is expressed in the decimal format, it is either terminating. If it is not terminating, then it is recurring. Irrational numbers, on the other hand, are non-terminating and non-recurring. Okay. Now the collection of rational numbers and irrational numbers together is called as real numbers, isn't it? So real numbers are expressed with capital R. See, we know that different sets of numbers have a certain way of denoting, right? So in the case of natural numbers, we represent, or we express natural numbers with capital N. We denote whole numbers with capital W, right? We denote integers with capital Z. We denote rational numbers with capital Q. Similarly, in the case of real numbers, we denote it with capital R. Okay. So if you take the case of rational numbers, we know that rational numbers are closed under addition, subtraction, multiplication, but it is not closed under division. But the set of rational numbers excluding 0, if you exclude 0 from the set of rational numbers, then they are closed under division as well. Okay, so now the set of irrational numbers, if you take set of irrational numbers, if you take sum of two irrational numbers, it could be a rational number. If you multiply two irrational numbers, it could be a rational number. For example, if you multiply square root of 2 with itself, you get 2 as the answer, which is nothing but a rational number. Similarly, when you subtract two irrational numbers, you will end up getting a rational number. And if you divide two irrational numbers, you get a rational number. Root 2 by root 2 is 1, so which is a rational number. Okay, so in the case of irrational numbers, we will not be able to say that it is closed under addition, subtraction, multiplication, or division. Okay, but the other properties that holds true for the rational number system, such as commutative property, associative property, distributivity of multiplication over addition. All those things holds good even for irrational numbers. Okay. What I suggest is, I wanted to give you a small exercise, right? You first find 1 by 7, right? Divide 1 by 7, express 1 by 7 in the decimal form. Okay, so once you have expressed it in the decimal form, you draw a small box, right, that has 2 rows and then 6 columns. Okay, you have 2 rows and 6 columns. The top row you mark it as quotient, the bottom row you mark it as second row, you mark it as remainder. So when you divide 1 by 7, okay, you put 1 divided by 7, right? The first, after the first division, the remainder that you get, you put it in the first column for remainder, which is in the second row. Okay, and the quotient you get, you just put that quotient digit value in the quotient column. Right. So in this case, let us say I am dividing 1 by 7. Okay, so 1 is less than 7, so I add a 0. I put a decimal point in the quotient. So 1 7s are 7. Okay, I put a 1. Right. So when I do 10 minus 7, I get a remainder 3. So in the first column, I will put 1 against the quotient. Right. So in the quotient row, the first column I will put 1, and in the remainder row, the first column I will put as 3. Okay. Now you further divide. You add a 0, it becomes 30. So 4 7s are 28. Okay, you get a remainder 2. So in the quotient second digit value, I put 4, and in the remainder second digit value, I put 2. Okay. So likewise, you keep dividing. You will find that after 6 digits in the quotient, right, your values will start repeating. I mean, after the 6 digits, once you have completed 6 digits in the quotient, again if you look at the remainder, it will be 1. So this block of 6 digits will keep repeating for 1 by 7. Okay, so you fill up this table, keep it with you. Do the same thing for 2 by 7. Okay, do the same thing for 3 by 7. Do the same thing for 4 by 7. And do the same thing for 5 by 7. You will be able to find a pattern based on the first quotient that you are getting. When you divide 2 by 7, based on the first digit in the quotient, you will be able to fill up the remaining digits without actually doing the division. Okay, so please do this exercise. This will basically help you to understand about the pattern of rational numbers when we say a block is getting repeated. Okay, so please do this exercise. We said irrational numbers are associative in nature. So when you add two irrational numbers, let us say root 2 plus root 3, right? So let us say root 2 plus within brackets root 3 plus root 5, it is equal to root 2 plus root 3 within brackets plus root 5. Okay, so it satisfies associative property. It satisfies commutative property as well. Okay, so if you have two irrational numbers, root 2 multiplied by root 3 or is same as root 3 multiplied by root 2, or root 2 plus root 3 is equal to root 3 plus root 2. It satisfies commutative property. It also satisfies the distributive property of multiplication over addition. Okay, so let us assume you have root 2 into root 3 plus root 5. It is equal to root 2 into root 3 plus root 2 into root 5. Okay, so this is something that we know about. We know about a distributive property. So I'm just recorrecting the distributive property, and it holds good even for irrational numbers. Okay, so before we progress further, in the next video we will talk about the process of successive magnification. Right, this is basically to identify where a particular rational number lie in the number line, and then we will talk about certain laws of exponents which irrational numbers also satisfies, and with that we will be coming to the end of this chapter. right, you will be in a position to try out exercises after the next video. So please wait for my next video. In case if you have any doubt, right, so far, please do not hesitate to email us at askmentorguru@gmail.com. ASKMENTOR guru GURU@gmail.com. Okay, so do not hesitate to write email to us. We will definitely respond back. All right. Okay, so we will meet in our next video. Until then, bye bye.